large scale. So generator is rated in megawatt, and the transformer what we use also in megawatt. Usually it was a step-up transformer. So a power station may have hardly 1500 megawatt capacity. That is in the macro grid, large scale. But in the case of a small renewable energy sources like solar PV or battery, so these are very small amount of energy. For example, in Kerala, battery illada need illennu parayunnunde. Ellavരുടെ വീട്ടിലും ഇൻവെർട്ടർ വന്നു കഴിഞ്ഞു. ചില ആൾക്കാർ എനിക്ക് തോന്നുന്നു സോളാർ പി വിയും ഇൻ്റഗ്രേറ്റ് ചെയ്തിട്ടുണ്ട്. ഒരു 5 കിലോവാട്ട് 10 കിലോവാട്ട് അല്ലേ. അപ്പോൾ this setup is already there in our home. ഇപ്പോൾ മെയിൻ പ്രശ്നം സോളാർ എനർജിയിലെ the interruptions what we face during cloud passing event. So particularly Kerala State Electricity Board, they are facing a critical issue due to the solar energy. Even ഒരു 10 വർഷം മുമ്പ് ഉണ്ടായിരുന്ന ടെക്നിക്കൽ ചാലഞ്ചസ് കമ്പയർ ചെയ്യുമ്പോൾ ഇപ്പോൾ ഭയങ്കര കൂടുതലാണ്. യു നോ വൺ മോർ തിങ്, 5 വർഷം മുമ്പ് ജനറേഷൻ ഓഫ് സോളാർ പി വി permissible for 40% of the capacity of the transformer. ഇപ്പോൾ ഡിസ്ട്രിബ്യൂഷൻ ട്രാൻസ്ഫോമർ 100 kVA പൊതുവെ നമ്മൾ കാണുന്നു, 200 kVA. അപ്പോൾ 40% എന്ന് പറയുമ്പോൾ 80 kilowatt മാക്സിമം. 80 kilowatt എന്ന് പറഞ്ഞാൽ ഇപ്പോൾ ഫോർ എക്സാമ്പിൾ 5 kilowatt per home. അപ്പോൾ കൂടി പോയാൽ ഒരു 20 ഹോം, 20 വീടുകളിലെ പെർമിഷൻ കൊടുക്കുമ്പോൾ തന്നെ അതിൻ്റെ കപ്പാസിറ്റി സെറ്റ് ചെയ്തിട്ടുണ്ട്. പക്ഷേ ഇപ്പോൾ റീസെൻ്റ്ലി ഒരു 4 വർഷം മുമ്പ് ഗവൺമെൻറ് റെഗുലേഷൻ മാറ്റി 100% വരെ പോകാണ്. ഇപ്പോൾ ഫോർ എക്സാമ്പിൾ ഒരു 100 kVA ട്രാൻസ്ഫോമറിൽ കണക്ട് ചെയ്തിരിക്കുന്ന വീടുകൾ എന്ന് പറഞ്ഞാൽ ഒരു 100 വീടുണ്ടാവില്ലേ, 100-150 വീടുണ്ടാവും. അതിലെ ഈ 5 kilowatt സോളാർ പി വി ഇൻ്റഗ്രേറ്റ് ചെയ്യാവുന്ന ഫെസിലിറ്റി 20 വീടുകൾക്ക് കൊടുക്കാൻ പറ്റത്തില്ലായിരുന്നു. ബട്ട് നൗ എക്സീഡഡ് ടു full capacity, 90%.
As a startup is doing.
Oh, yes, it's rather more.
Increase to 70%, then
increase
to 90%.
Yes. Now the problem is, although they are permitting to increase the solar PV, especially in Kerala, the peak demand is coming in the evening time. And one more thing, they have observed very clearly in the past 2 years, charging of electric vehicle. ഇപ്പോൾ നമ്മൾ റോഡിലെ കാണുമ്പോൾ ആൽമോസ്റ്റ് 10 in 1 vehicle is electric vehicle. 2-wheeler, almost 40% vehicle are 2-wheelers in electric category. 5 വർഷം മുമ്പ് very rarely we can see 2-wheelers and 3-wheelers particularly. ഇപ്പോൾ കോഴിക്കോട് വന്നു കഴിഞ്ഞാൽ ഒരു പകുതി ഓട്ടോറിക്ഷ ഇലക്ട്രിക് വെഹിക്കിളാണ്. കോഴിക്കോട് വെരി വെൽ ഓട്ടോറിക്ഷ മെയിൻ ട്രാൻസ്പോർട്ടേഷൻ സെക്ടർ ഇൻ സിറ്റി. Almost 50% they have electric vehicle. But the problem is when they are charging, especially from utility grid, the main problem is harmonics. You know this when the load is converting into a non-linear load, so most of the time the non-linearity is not that much severe. You have a lamp, for example, ഇപ്പോൾ നമ്മൾ പഴയ LED lamp, incandescent lamp മാറ്റി LED ആയിട്ട് more than almost 10 years they are using. But the problem was not very severe. The reason is power 10 watt, 20 watt, even people go for BLDC motor. If you take the power, that is also not very high, hardly 30 watt, 40 watt. But this electric vehicle charging is creating a very severe impact on the grid, especially for the past 2 years. What the survey says, almost the failure rate of 100 kVA transformers significantly increased in the past 2 years because of the triple M harmonics. Harmonics, I think, everyone knows. So why we stick on the sine wave? You know, Vm sin omega t, Vm sin omega t minus 120, minus 240. These are the 3 waveform we take. As a single phase, വീട്ടിലേക്ക് R phase or Y phase or B phase or എന്തെങ്കിലും ഒരു phase എടുത്ത് single phase ആക്കി നമ്മൾ ഉപയോഗിക്കും. But the problem is the harmonics. If we take the fundamental as Vm sin omega t, the order of third will be Vm by 3 sin 3 omega t. But if we see the B phase, so 120 into 3 is 360. So sin of omega t minus 360 is also sin omega t. So 240 into 3 is also sin omega t. So the triplet harmonics like 3, 3, then 15, 9, those category produces something like a triple harmonics which is termed as a neutral current. But a neutral current is a problem. If you have a star connected system, this neutral current exists because I neutral is equal to IR plus IY plus IB. But a delta connected system model it will turn as a zero sequence component. That zero sequence component revolves through the delta winding. So it overheats the transformer. And not only that, the main thing is the core loss. Core loss is proportional to the frequency sometimes, the numerical value is there. So that is also increasing because the frequency of fundamentally is 50 Hz, but the third order is 150 Hz. So naturally the losses significantly increases, transformer overheats. So because of that, although we call the transformer achieves the efficiency of 98%, the transformer efficiency degrade more than 90 to 90 sometimes. So 100 kVA, if you take the efficiency of 90%, so 10 kilowatt is the power. So you can imagine what is 10 kilowatt. 10 kilowatt, 1 hour of time, it is almost going to consume 10 units of electricity. So, we have very AC, we file 1 unit in vehicle. So 1 unit is 10 times. I am telling one distribution transformer of after all 100 kV. So now you can imagine, only because of the triple harmonics, the environment is highly polluted in terms of poor quality power. So KSEB predicting our area, government already passed the bill that by 2030, almost 50% of the vehicle will become electric. And wherever survey I know, if we take the usage of vehicles, America number of cars close to 400. Europe number of cars close to 600. 1000 பேர் இருந்தீங்க 600 பேர் கார் ஓடிக்கிறீங்க. பட் இந்தியாவிலே 1000 பேர் இருந்தீங்க 25 ஆளுங்களே கார் ஓடிக்கிறீங்க. But the two wheelers are very high. Two wheelers almost more than 400. See, 2030 definitely all the vehicle will be electric vehicle in the case of two wheelers and three wheelers almost. But car, I don't know whether everybody will change into car as an electric vehicle. That's a question mark. But there is no doubt that these two wheelers and three wheelers will create a severe impact in our entire distribution system. That's what I am integrating this vehicle in the distribution system as a single phase load. For example, electric vehicle two wheelers or 48 Ah battery. 48 Ah, for example, you are charging from single phase, and the charging time, assume that it is 1 hour. After what is the current? Almost 48 Ah, it is 48 volt, but it is easy for calculation. So 1 ampere current. Here 1 hour, 1 ampere current is the DC side. But now what will happen to the AC side? So 230 volt, I think if you want to produce 48 volt DC, the other side you are maybe having around 300 volt, for example, for calculation purpose it will take 400. So 50 is your DC battery voltage, 400 is your AC voltage. So the 8 times the input voltage. So 8 into 50 will be 400 volt. Now 8 times the voltage is more and the current is sometimes 8 times less in the AC side. Now 1 ampere, if you take how much it will come? 1 by 8 will be there. I am telling if it is the 48 Ah battery. For example, if you take, there are 100 consumers, because a 100 kVA transformer, on an average they have 100 ohms. Now everywhere people are going to use two wheelers. And what will happen to the magnitude of current? It will be very significant. Right. One very predominant problem I would like to focus here. Assume that we have a nearby industry which is connected to the current distribution transformer. Okay. If an induction motor is powered using a Vm sin omega t, Vm sin omega t minus 120, Vm sin omega t minus 240, you know what is a revolving field? I think all of you definitely might have either teach or studied this revolving field theory. Suppose I am going to power using a non-sinusoidal wave where there are harmonics. But what will happen to the fifth order harmonics? Third order we already told. All three phases will be in phase and you will have a triplet harmonics. It will never produce any revolving field because revolving field when you move waveform and 120 degree apart. Unfortunately, in the third order, all three phases are coincide each other, in phase each other. So there will not be any revolving field by this third order. But what about fifth order? So it is 120 into 5. So 120 into 5 will be 600. So 600 is equal to minus 240. So what will happen if you investigate very thoroughly? For the fifth order component, the rotating field will be the opposite direction of the fundamental order. Assume that the fundamental Vm sin omega t minus 120 minus 240 in anti-clockwise direction. This fifth order waveform will make a rotating field in the clockwise direction. Now you can imagine. So one fellow is pulling in the other side, where the fifth order is pulling in the opposite direction. So what will happen? It will produce not only the reduction of speed, it will produce a pulsating torque. So if it produces a pulsating torque, what will happen to the rotor? Crack will be developed on the rotor will damage. Now you understood the problem very severely. So we use the fan right? What is the reason? This is electric vehicle. Because there are many people doing research in electric vehicle, you understand how much depth the problem is. If you investigate, after all, the effect of fifth order harmonics on the conventional load, that itself will be a very good research study. I am telling only fifth order harmonics. So Vm sin 5 omega t, Vm sin 5 omega t minus 240, Vm sin omega t minus 120. I am telling you the phase will be reversed. You know, usually in induction motor, if you want to change the direction, what you will do? Change the phase. Once if you change the phase, motor direction can be changed. Right, any direction you can move. If it is a three-phase motor, instead of RYB, if you do RVY, it will change the direction. Same thing happened in the fifth order harmonics. Understand? What will happen? Rotor will create a pulsating torque. Pulsating torque is one of the threatening factor in most of the domestic as well as industrial loads. You may think that, sir, this is actually single phase. What is the problem? So single phase is in our home only, but what is altogether? Altogether is a three-phase system. You don't misunderstand that, sir, I am single phase or I am safe. It is not like that. The net result is on the three-phase system. So what I am telling you, only if you take a fifth order harmonics and integrate these non-linear loads like electric vehicle, chargers, like particularly charger, and try to understand what will happen to the effect of these charges on the grid infrastructure as a power system problem. Right? The interest of study is in terms of seconds to minutes. You can understand, investigate the transient stability of the system due to these harmonics, and you can understand what are all the impact it is going to create on the domestic consumers. Okay. So that will be a very good PhD problem. If you take fifth order, then I am not taking about any solutions. You know, I never found a solutions. So when you suggest a solution, there are two-way solutions are coming up. One is, as usual, designing a passive filter. Second one, designing an active filter. You know, the problem creator is a power electronics. Then who is the problem solver? Is also a power electronics. Okay. Problem creator is a power electronics. Solution is also power electronics. So what you can do, the charger, what you are going to use here is again AC to DC converter. It can act like an active filter. I think all of you will read about active filter. The passive filter actually removes the unwanted component. active filter injects the opposite phase harmonics into the system. It is also introducing harmonics only, but it is antiphase. Suppose you have a triple order harmonics like this, exactly 130-degree phase shift we include in the system. So what will happen? Both of them will cancel each other. So that is the basic principle of an active filter. So why I am telling you, most of the time when you see electric vehicle is having a charger, it doesn't matter if it is a 1 kilowatt or 5 kilowatt, means fast charger or maybe a level 1 or I think somebody may have discussed level 1, level 2, level 3, maybe any category, but you are not going to use the charger for 24 hours. If you plug into electric vehicle, maybe for charging electric vehicle, hardly it takes 8 hours. And that too, if you see very clearly, if you take a 48 AH battery, almost 80% SOC reaches in half of the time. Suppose if the charging time is 5 hours, 2.5 hours it takes to charge 80%. Remaining 20% in another half an hour. And that too, the last 10%, almost 2 hours of time. If you investigate, that is called cell balancing. You know that, otherwise this hot spot will be developed inside the battery will damage. So to overcome that, what they are doing, cell balancing is one of the primary process of every lithium-ion battery cell. You know, these modern batteries are made up of lithium phosphate or maybe lithium ion or any category. There, the cell voltage balancing is one of the major topics. Recently, one of the professor at NIT Calicut, he has given a suggestion. The same suggestion I am just transferring here. Most of the time, we start a MTech branch in high voltage engineering, right? Now, high voltage engineering no admission. Most of them, including IAC, they closed. NIT Calicut, we are surviving, but high voltage is one of the branch where there is no much demand at present. Okay. This professor is giving an idea, start high current engineering. The reason is, for example, you take same electric vehicle category, 48 volt is the battery voltage. If you see the power, 2 kilowatt. For calculation easy, I am taking 50 volt. If it is 1 kilowatt, it is 20 ampere DC. If it is 2 kilowatt, 40 ampere DC. Then what about the thickness of the wire? You know, 2.5 kg wire, hardly is 25 ampere or 12 ampere, we say in that case, 12 to 15 ampere, we put that 2.5 square wire. Then if you talk about this 40 ampere, the car jumper wire can be down 12 volt battery car. And the jumper wire thickness can be down. But in Yamara, 40 ampere 2 kilowatt. If 5 kilowatt, 5 kilowatt, 100 ampere. 100 ampere, but 100 volt 100 ampere. Yeah. For example, one cable resistance 1 ohm. What is the power loss? 100 square times 1. 100 into 100. 10,000. 80 kilowatt loss. The electrical engineer resistance DC machine experiment lab 230 volt DC machine experiment armature resistance measure value 0.1 ohm maybe 0.15 ohm measure 1 ohm 1 kilowatt. But if your ampere is 100 ampere, 100 ampere is a current. If your cable resistance is 0.1 ohm, which is supposed to be treated as a minor value of the resistance, how much power it is going to incur in the system? 1 kilowatt. So 10 kilowatt charger in the 1 kilowatt loss in the volume of loss. Maximum achievable efficiency is only 90%. But this professor is suggesting definitely we should start an MTech branch in high current engineering. The entire world very happy about high voltage engineering. 1000 kilovolt transmission. So voltage is a current on main person. So 5 kilowatt system 48 volt is almost matured enough. When fuel cell, ബാറ്ററി, സോളാർ PV ഇത് എല്ലാത്തിലും 48 വോൾട്ട് സിസ്റ്റം അല്ലെങ്കിൽ സ്റ്റേബിൾ ആയിരിക്കും. അല്ലെങ്കിൽ 72 വോൾട്ട് സിസ്റ്റം ഇതിൽ വലിയ ഡിഫറൻസ് ഒന്നുമില്ല. പക്ഷെ എന്നാലും ഈ കറണ്ടിന്റെ വാല്യൂ നമ്മൾ പറഞ്ഞ ഈ 0.5 ആംപിയർ, ഇവൻ നമ്മുടെ ഈ ഫാൻ LED ഒക്കെ 10 വാട്ട് 20 വാട്ട് എന്ന് പറഞ്ഞാലും 230 വോൾട്ട് സ്കെയിലിൽ ആ കറണ്ട് ഈസ് വെരി സ്മോൾ വാല്യൂ. 0.1 ആംപിയർ കറണ്ട്, 0.2 ആംപിയർ കറണ്ട്. അപ്പോൾ 1 square mm ഉപയോഗിച്ചാൽ പോലും നത്തിങ് വിൽ ബി മോർ ഇൻ ടേംസ് ഓഫ് വോൾട്ടേജ് ഡ്രോപ്പ്. നിങ്ങൾ 1 square mm ഉപയോഗിക്കുന്നില്ലേ, we recommend, yeah, 1.5 maybe 1 very easily we use. The cost is hardly 2,000 rupees, 3,000 rupees for 90 meter. But what about this 100 ampere cable? Now you think about high current handling capacity, particularly inverter. So inverter il eduttal battery inverter ആകെ ഒരു 1 meter cable ആയിരുന്നു ഉപയോഗിക്കുന്നത്. അത് കണ്ടിട്ടുണ്ടാവും തന്നെ, ഒരു 1 meter cable. അതിന്റെ റെസിസ്റ്റൻസ് ഒരു LCR മീറ്റർ, മൾട്ടിമീറ്റർ ഉപയോഗിക്കാൻ പറ്റില്ല, കാരണം വെരി ലോ റെസിസ്റ്റൻസ്. അപ്പോൾ ഞാൻ പറയുന്നത് ട്രൈ ടു യൂസ് an LCR മീറ്റർ. അപ്പോൾ അതിന്റെ റെസിസ്റ്റൻസ് പോലും മിനിമം 0.2 ഓം ഉണ്ടാവും. ദെൻ അനദർ വൺ IC പാക്കേജിംഗ്. നമ്മൾ എന്തായിരുന്നു ഉപയോഗിക്കുന്നത്? സോൾഡറിംഗ് ആണ്. സോൾഡറിംഗ് ചെയ്യുന്ന സമയത്ത് കോൺടാക്ട് റെസിസ്റ്റൻസ് ആണ് ഞാൻ മെഷർ ചെയ്യുന്നത്. കോൺടാക്ട് റെസിസ്റ്റൻസ് ഇല്ല. Contact resistance, I think if you see very seriously, contact resistance is playing a major problem in PCB of these high power applications. Soldering, soldering is not just to IC edukka and solder it, it is not such a simple matter. Okay. നമ്മളിപ്പോൾ മെഷീൻസ് ലാബിൽ എങ്ങനെയാണ് ഈ എക്സ്പ്ലോർ ചെയ്യുന്നത്? ഒരു ബനാന പ്ലഗ് ഉണ്ടാവും, ജമ്പർ വയർ ഉണ്ടാവും, എന്നിട്ട് നമ്മളിങ്ങനെ കൂട്ടിപ്പിടിച്ച് ത്രെഡൊക്കെ എടുത്ത് ചെയ്യും. പക്ഷേ if you measure the contact resistance, that is in terms of some 0.2 ohm or 0.3 ohm. So it is very easy to say in high voltage system or maybe 230 volt system, but now you understand it is very difficult in 48 volt system. Why? The current is 100 ampere. Okay, if 5 kilowatt is usually we go in our domestic system in single phase or maybe in 3 phase, because you all might have definitely see your 5 HP induction നമ്മുടെ ഫ്ലോർ മില്ലൊക്കെ പോയവർ നോക്കാം. 5 kilowatt ഇൻഡക്ഷൻ, 5 kilowatt BMS ആരെങ്കിലും 5 kilowatt BMS 1/10 of the size of the induction. ഭയങ്കര വളരെ ചെറുതെന്ന് പറഞ്ഞാൽ even could not imagine the power density of a BMS motor is such a small machine. പക്ഷേ ഇപ്പോൾ ലോകമൊക്കെ BMS പുറകിലാണ് പോകുന്നത്. അതുകൊണ്ട് വൈ? ബിക്കോസ് BMSM is a magnet motor, so we need a magnet. China is one of the leading country in the world who hold 90% of the resource of this magnet. Europe, US അടക്കം പറയുന്നു don't go behind this BMSM. Why? Because this material, if you want to manufacture the material, China is one of the leading country in the world. അപ്പോൾ നമ്മൾ എല്ലാവരും ചൈനയുടെ പോയത്. Now itself almost China started to dominate the entire country in the world, you know very well. But ചൈനയുടെ പ്രോഡക്റ്റ് ഇല്ലാതെ ഒരു വീട് ഇന്ത്യയിൽ കാണിക്കാൻ പറ്റും. നമ്മുടെ വീടുകളിലെല്ലാം നമ്മൾ ഉപയോഗിക്കുന്ന ഇപ്പോൾ എൻ്റെ ഫോൺ അടക്കം ചൈന പ്രോഡക്റ്റ് അല്ലേ? ചൈനക്കാരാണ് ശരിക്കും സമ്മതിക്കുന്നത് അല്ലേ? പല FDP ഒരു കഥ പറയാറുണ്ട്. പ്രശ്നം എന്താ പറയാം, നേരത്തെ FDP അറ്റൻഡ് ചെയ്തവർ വെച്ച് ക്ലാസ് എടുക്കുന്നത് ഭയങ്കര പാടാണ്. ഈ സാർ എവിടെ പോയി ഇതേ കഥയിൽ പറയുന്നുണ്ട് കേട്ടിട്ടുണ്ടെങ്കിൽ ദയവ് ചെയ്ത് തിരിച്ചു പറയുന്നത്. അപ്പൊ ഇവരൊക്കെ ഇവിടെ കണ്ടതായിട്ട് ഓർമ്മയുണ്ട് അല്ലേ? അങ്ങനെ ഏത് കോളേജാണ് മൊത്തപരിചയം ഇവർക്ക്? ഇവിടെ തന്നെയല്ലേ എന്റെ FDP നേരത്തെ നിങ്ങളുടെ കോളേജില്ല. അപ്പൊ ആ കഥ കേട്ടിട്ടുണ്ടാവും. കഥ എന്താന്ന് പറഞ്ഞാൽ you all know White House. White House ഇല്ലേ, അമേരിക്കയിലിരിക്കുന്ന White House, where the President of America is staying. ആ White House വൈറ്റ് വാഷ് ചെയ്യാൻ തീരുമാനിച്ചു. White House വൈറ്റ് വാഷ് ചെയ്യാൻ തീരുമാനിച്ചു. സോ ഗവൺമെന്റ് ഇല്ലേ, അപ്പോൾ ടെൻഡറൊക്കെ വിളിക്കണ്ടേ? അപ്പോൾ ടെൻഡർ വിളിച്ചിരുന്നു. അപ്പോൾ ടെൻഡർ വിളിച്ചപ്പോൾ 3 കൺട്രിയാണ് വോട്ട് ചെയ്തത്.